In my experiment, I investigated the effects of coal-burning power plants on residential areas, specifically their effects on air quality and health of local residents. I wanted to know how air quality near a coal plant varies from air quality further away from a plant and what negative health effects, if any, do local residents experience. I hypothesized that air quality would be worse near a coal plant compared to further away, with elevated levels of sulfur dioxide and nitrogen dioxide and mercury. I also hypothesized that residents would experience higher rates of respiratory illness compared to other residents in the county and residents of the state. In the first part of my experiment, I surveyed residents living closest to the coal plant with questions about their respiratory health that you can see here if you pause the video. I found that 49% of children suffered from some type of respiratory condition, whereas 34% of adults did. I was not surprised that the rates of respiratory illness for children were higher than for adults because, due to children's physiology, they are much more susceptible to respiratory illnesses at their young age. To analyze my data, I compared the respiratory illness rates from my surveyed area to census data of respiratory health for the county in which the coal plant is and for the state. I found, using a chi-square analysis, that for children, the two variables, location and respiratory illness, were related. However, for adults, the results were not statistically significant, thus partially proving my hypothesis. For the second part of my experiment, I conducted air tests for carbon monoxide, sulfur dioxide, and nitrogen dioxide in 4 different locations. I measured levels of carbon monoxide not because they are emitted in large quantities from coal plants, but because they are emitted from vehicles, and I wanted to make sure any increased air pollution readings that I may or may not get were from the coal plant and not from heavy traffic. I found that there were elevated levels of sulfur dioxide and nitrogen dioxide compared to their controls. I also tested for mercury in the soil. They could not test for mercury in the air, so a lot of other variables were presented. However, I did find that mercury levels continued to stay elevated even when levels of airborne pollutants dropped off. My hypothesis was proved for sulfur dioxide and nitrogen dioxide.